Okay, this is the third and the uh, final basic law of on gases, law of pressure, right? So if you've seen the video on Charles's law, if you're not done, then I would strongly recommend you to do that because it's a repetition or very similar to Charles's law. So our discussion also you'll see is very, very similar to that. So in law of pressure, right, Gay-Lussac is given the credit for law of pressure, and it says that at constant volume, pressure of the gas is proportional to temperature. So again, we have the same thing, that you have a gas system, right? And let us say the temperature is 0 degrees Celsius and the corresponding pressure is P0, right? And the temperature then goes to T1 degrees Celsius and the pressure is P1, and T2 degrees Celsius, the pressure becomes P2. Okay? So what is observed is that constant volume. So if I keep the position of the piston fixed, that means I don't allow this volume to change at all. And if I increase the temperature by giving it, what will happen is that the pressure will increase, meaning the particles of the gas will start moving very fast. There will be a lot of motion happening over here. These particles will hit the container of the vessel more frequently, thereby increasing the pressure. Conversely, if I decrease the temperature, pressure will decrease. Right? So this is the basics, this is the base of law of pressure. Right? And again, we will do the same thing as we did in the previous video on Charles' law. Let us say we plot a graph of pressure versus temperature. Right? Pressure versus temperature. Right? So temperature in degrees Celsius, so this becomes 0 degrees Celsius, and let us say this is temperature T1 degrees Celsius and temperature T2 degrees Celsius. And since pressure is proportional to temperature, again what will happen is we'll get a straight line graph. Right? This is P1, this would be P0, and this would be P2. And if I extend this, do extrapolation, at this particular point the temperature will be minus 273.15 degrees Celsius, which you know is known as absolute 0 Kelvin over here. This will be 273 Kelvin. Again, this is T1 plus 273 Kelvin, and this is T2 plus 273 Kelvin. Exactly same argument as we had in the previous case. Right? And again, in this video, I will not take up too much of time talking about the Kelvin scale, the 0 scale we have discussed in the previous video. No molecular motion, right, at 0 Kelvin or minus 273.15 degrees Celsius, known as absolute 0. Okay. Again, we will do the same thing. We'll identify the triangles that we are focusing our attention on. So we call this O, A, B, C, D, E, F. Right? And let us say first we are focusing on triangle OCD. Right? If you look at OCD, right, P1 minus P0, right? P1 minus P0 upon P0 minus, the pressure over here is 0, so P0 minus 0. P1 minus P0 upon P0 by P0 is equal to T1 minus 0 degree, 0 minus minus 273. Right? So this will give me T1 minus 0 upon 0 minus minus 273. Right? So this is how we are looking at pressure, and therefore if I do simple calculation, P1 minus P0 is equal to P0 into T1 upon 273, and this will give me P1 is equal to P0 plus P0 T1 upon 273, T1 273, and this I can write as P1 is equal to P0 into 1 plus T1 upon 273, and therefore P1 is equal to P0 into 273 plus T1 upon 273. So this is the equation that we get. You could have small p or capital P as to indicate pressure. Generally capital P is used. I have used the lowercase p1. Right? Okay. Next we'll focus on the triangle OEF. Right? OEF. So here we'll get P2 minus P1 upon P1 minus 0. Right? So P2 minus P1 upon P1 minus 0 is equal to T2 minus 0 upon 0 minus minus 273. Again, if I do the same calculation over here, I'll directly now write this equation. P2 will be equal to P0 into 273 plus T2 upon 273. Right. Now if I take the ratio of these two equations, P1 upon P2 is equal to P0, P0 will get cancelled, 273 get cancelled. So I'll get the equation 273 plus T1 upon 273 plus T2. And as you can see over here, 273 plus T1 is, this we call as T1 Kelvin, this we call as T2 Kelvins in Kelvin scale. So this is T1 upon T2 in Kelvin scale. T1 is in degree Celsius, T1 is in Kelvin scale. And therefore I write P1 upon P2 is equal to T1 upon T2. Right, and this is the statement of law of pressure. Of course, this is applicable at constant volume. So at constant volume, P1 upon P2 is equal to T1 upon T2. Also can be written as P is proportional to T. Right. So we have looked at all the three laws of gases: Boyle's law, Charles' law, and law of pressure, and we have obtained a relationship, a mathematical relationship for these laws in terms of absolute temperature. And in the process, we also tried to look at absolute zero temperature. In the next videos, we will continue to look at other laws of gases, like the equation of state, right? Graham's law of diffusion when we discuss thermodynamics. Thank you.